Hello. Okay, I hope everyone is healthy and well. And we're going to start off this first video talking about some things with power functions. Remember, power functions were these awesome functions that look something like this. F of x equals 2.1 x to the 0.7 is an example. The important things with a power function are they are only one term. Unlike other functions like polynomial functions. The other thing is this exponent up here can really be any number. So power on x, power on the input variable, can be any number. And that's something that's definitely not true for polynomials. Polynomials, you have to have nice, round, positive, or zero exponents. And the really big deal right now with power functions is we're going to talk about variation, direct and inverse variation. I'm going to kind of describe the theory of it, and then we'll look at a bunch of examples. So by definition, if you see something like this, y equals ax to the b. Oh, by the way, anytime I talk about a here, it's going to be positive. And in this case, we're going to say b is positive also. Okay, remember your variables are x and y. Those are your variables, input, output. A and b are going to be some set constants. If you see something like this, this is called direct variation. The idea is, as x gets bigger, as long as this exponent is positive, y will also grow larger. So they work kind of in tandem. This gets bigger, this gets bigger, this gets smaller, this gets smaller. Then we'll also see things like this. Y equals a over x to the c. C is a positive number. This is called inverse variation. And here the idea is, remember, when you have a number in the denominator that's growing bigger and bigger, and if c is positive and x is growing large, then this denominator will grow very large. A large denominator means a small overall number. As this grows bigger, the whole thing grows smaller. So with inverse variation, you're going to see as x grows larger, your output, the y variable, grows smaller. Okay, let's look at some examples. Say that we had y equals 3 times x to the 0.7. So this is definitely a power function. We have one term, the power on x. It's allowed to be anything. So are we in direct variation or inverse variation? This one's pretty simple. The a is the 3. This is a positive exponent on x. X is being multiplied right by 3. So this is definitely direct variation. And if you were going to graph it, it would look something like this. Your inputs, your outputs, and the actual function would look like this. As your x variable is getting larger, your y variable is also growing. It happens to start slowing down its growth as x gets bigger, but it's still growing, it's still increasing. Over here it was growing really fast, a little bit slower, but still growing. So as x increases, y increases. In this function, in this relationship, and it's obvious in this graph, this is a marker of direct variation. Another example, if we had y equals 7 over x to the 2.3, we think, okay, which case are we in? Well, this is a positive exponent on x, but x is in the denominator, so this is definitely inverse variation. If I were going to graph this, I'd see something, there's x and y, I'd see something that looks like this. And you could try this on Desmos, try to graph it, and you'll see. Here, as x increases, y decreases. This is an attribute of inverse variation. One more example real quick. Y equals 4x to the negative 1.3. So we ask ourselves, is this direct variation, inverse variation, neither? I thought this exponent was always supposed to be positive. Well, at this point, we can remember that if you do have a negative in an exponent, you can rewrite it. This is really like 4 over x to the 1.3. That's what a negative exponent means, that it just, in this case, shifts it down to the denominator. Knowing that these are all equal, we now know that we're in this case. This will be an example of inverse variation. Even though from the beginning it wasn't totally obvious that it was, it almost looked more like direct variation, but it is inverse variation, and if you graphed it, you'd see something that looks like this. One other thing to mention is A, this number, or this constant that we talked about here, here, and here. This A, this number, here it's 3, here it's 7, here it's 4. This is a constant that gets multiplied by the input variable. A is called the constant of proportionality. And we'll see that phrase in the homework. Also, one thing to notice is there's different wording besides direct and inverse variation. Sometimes people will say, oh, those are directly proportional. Directly proportional means direct variation. It's just another way of saying it. And you might see they're inversely proportional. And it's the same story. So those two phrases will mean the same thing. Okay, next video we'll look at some more specific examples.